Hey, what's up? Welcome back. This is day 14 of the Advent of Code. This exercise is called polymerization, and the idea is that you get a template that is a string template that has some letters in it, and then you also get sort of a mapping between pairs of characters and another character that when you encounter that pair inside of the template, you sort of like split the pair apart and insert that letter in between the two. And you work your way through the entire template until you have updated all of the pairs. And so at each step, you sort of replace pairs of characters with the triple of characters with that new letter inserted. So here, where we used to have NNCB, NN maps to C. So here we have NN and it maps to the letter C. So the resulting pattern or the resulting template after step 1 is NCN. So we're sort of like sticking in the C in between. This grows super quickly. So after step 5, we are going to have 97 characters. This just shows us steps 1 through 4. And what the problem is asking us to do is figure out, after we have gone some number of steps, we're going to find some key that we're going to enter. That's going to be our solution and our answer. And the key is created by finding the most common letter and subtracting its occurrences from the least common letter. So let's get into it. So we're going to create a new thing called day 14, and we'll call it polymer.rb. And we'll also need to create a spec, day 14 spec.rb. And let's jump into it. So we're going to require relative day 14 polymer.rb. We're going to describe polymer, and it should replace a known pair with its, like, I don't know, mapped letter. We'll create polymer as polymer.new and pass in the template. So let's use the template. Actually, let's make our own template so that we can control it. All right, so we will make our template ABC. I guess we'll also need to pass in, okay, so we're gonna pass in the template, but we also need to pass in the mapping. So our input looks like this. It's gonna be the template and then a new line and then all of the mappings. So our mapping is gonna be a dictionary where we'll pass in pairs of letters and what those map to. So we'll have AB map to A and BC also map to A. And what do we get after that? So I guess we can say polymer.step, and we'll expect that polymer.template to equal something. What is it going to be after that first step? Well, AB is going to be replaced by AAB. And so one way we can do this is just write ABC. And then what letter is going to be inserted between A and B? Well, A is going to be inserted because that's what we map to. And then what letter is going to be inserted between B and C? A. So this is what we should end up with after we make a step with the polymer. So let's go solve this. So class polymer is going to start off, I guess we might want like a method to parse. I don't know. Should we have the parsing happen as part of the driver? Unclear. So let's take in the template and let's take in the mapping, and we'll just store those. Template is template and mapping is mapping. And I'm not sure if we want to store the template as an array or how we're going to interact with it yet. We also need some method step. And let's run our test again. Undefined method template for polymer. So let's just make that a reader template. And as we step, we'll just keep updating the underlying template object. Okay, so now in order to take a step, what we need to do is, I guess what might make sense is iterating through, or maybe creating, yeah, so if we iterate over all of the pairs. So if we say template.chars.each cons 2, that will give us all of the consecutive pairs together. Dot, I guess like do pair. And we could even deconstruct this into like A and B. And I guess what we want to do is say, or maybe let's keep it as pair. I don't know. Pair. And we need to know what character we're going to insert. So character is going to equal mapping at pair, because the mapping is going to be, pairs of letters to a single character. That's right. And then what we want to ultimately return is we want to kind of like collect up the results maybe into an array, results, and we can just join those later. So maybe if we say something like results push, I guess we want to add on, let's see, A and B is the pair. So we want to add in A, then we want to add in B or char, and then we want to add in B. And I'm not sure if that's going to work. Let's just see. Okay. Right. So then we want to update at template equals results.join. Day 14 spec. Close. Close. So we were expecting A, B, A, C, and we got A, B, B, C. So from ABC, we inserted something, but it's not what we expected. So let's debug this. So we'll open up require debugger, and or I guess by bug. I don't know. There's a new debugger that's getting popular again that I feel like maybe we should try out or use in one of these. We'll see. Okay, so our pair A is A and B is, whoops, oh yeah, puts B. Okay, so then char is nil. Why is char nil at mapping? Okay, so mapping of pair. Oh, pair is going to be, okay, so we need to join that, pair.join. So this should be pair.join, and then we can run it. Okay, there we go. Close. All right, so now we have a duplicate B in there somewhere. So why do we have the duplicate B? I don't know. I guess, why do we have a duplicate B? A, B, B, C. So I think we might only want to add A if we're at the very beginning or something. So maybe results should be something like template.chars 0, and then we just don't even put A in there at all. I don't know. Template. Okay, yeah, there we go. So the idea there is that every time we're looking at a pair, we will have already seen like sort of the head or like the beginning of the list. So we don't actually need to add that twice. So we'll remove our debugger here, and we can clean this up and just say results plus equals the array of char and B. And now we should have, cool. So we're able to sort of just build we're able to take one step. Okay, what is the next step here? Right, so after this, we want to count up the occurrences after step 10. Okay, so we want to step basically 10 times. So let's add some driver code here. So polymer, oh, we also need to parse out the input and stuff. So we're going to read lines and so actually, yeah, let's do this. So let's say file.read argv.first, and then split on 2 new lines. And that should give us a split like right here where there is a double new line. And then the first element that we're going to get back from that split is going to be the template, and the second element is going to be the rest of all this business. So we can say template and then lines, I guess, or something. And then we can say lines.map. So we want to split the lines on that arrow, I guess. Yeah, so lines.map line.split on this arrow. And then that will give us the pairs of sort of the left-hand side and the right-hand side. And that might be close. So let's just print those out. And let's add some example input here. So we're going to just grab this example input. And then we'll run this Ruby day 14. And when we run it, we see undefined method map for string. Why? Oh, that's because we need to split on new line. Okay, so this is what we get back. Pairs of, okay, so we have these, all of these pairs, and then I think, how do we get that into, yeah, that should just be, I guess, okay, so there's this, let's see if this works. Okay, so so the square bracket operator on the class itself is kind of another hack or another trick that is kind of interesting. So the hash class has like a square bracket operator. So we're not actually calling hash.new here. We're calling hash square bracket and passing in this array that has arrays that are all tuples. And the first value is going to become the key and the second value is going to become the value. That's like, there is a, like if you do hash.2a or sort or something, it spits out like an array of arrays like this, array of tuples. And then this is kind of the way to get it back into the other format. So this is our mapping. And we want to pass in both the template and the mapping. And then we want to say 10 times polymer.step. And then we want to say, I guess we need to, okay, so we need to count up, or we need to figure out, right, yeah, okay. So we need to figure out what the most common, or the value for the most common letter and the value for the least common letter. So let's say our score here is going to be, I guess, okay, so there's a couple like really cool things here that I was hoping to use. So one is called minmax. So I think what we can do is we can say at template.chars.tally, and that should, we looked at tally in the last episode. It's really cool. And that should give us, I believe that should give us, if we have something like A is A, B, C, A, B, A, B, A, B, A, B, C, 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 and we say a.chars.tally, then we get back the counts of each of those. And what we want to do then is say values and then .minmax, and that should give us back the pair of the minimum and the maximum. And then we can inject, oh gosh, this is fun. Inject minus .absolute value. Also, this looks so funny. Inject minus is like a smiley face. So I love that. And that is sort of like the answer. This is, I don't know, it's kind of fun. Tally values, min, max, inject, absolute value. I don't know how clear it is, but it's definitely fun. So let's try that. So we're going to tally, then we're going to say .values, then we're going to say min, max, then we're going to inject minus to give us back a score. And that is what we actually want to print out. So puts polymer.score, and let's just run it against the example input again, 1,588. And the answer here was 1,588. So let's get our puzzle input. Copy it, come back over here and say input, and drop it in. And then we can run this against our input. And we get back 3408. 3408. All right, so that is the end of part 1 for day 14 of the Advent of Code. Pretty simple stuff so far. Now, the next part gets a little gnarly. So part 2, you want to do a total of 40 steps. So if you imagine like it's growing this quickly, if you just turn your head a little bit, that's the kind of business you want, is one that just kind of goes like hockey stick up and to the right. But the result is going to be that if we try to run this 40 steps, I don't think it's going to work because it was even slow for 10 steps. So let's just run it, and it's going to keep going, and it's not going to finish because it gets way too big. Like using the approach of like maintaining the string value itself is going to get too big. So it just, yeah, it's not a workable approach. So if we look at sort of this example down below, we see that the most common element is B, and it occurs this many times. So what is that? So 2 trillion times or something, and then H occurs, I don't know, 3 billion times, and subtracting those ends up with this massive number. And so if you imagine the string that is like 2 trillion characters long, it's going to just like fill up memory. In fact, I'm going to kill this. So, okay. What we need to do is find, again, an alternative representation for storing these values. And we did this before with the ages of the fish in the school. I can't remember what day it was, but we went from using an array where we kept track of the ages to a dictionary. And so if we think about ways that we might be able to use a dictionary to solve this particular problem, then you might come again upon a dictionary as a solution. Now let's talk through it. So how do we want to actually store the keys? Well, if every time we're kind of considering these pairs and what those pairs are mapping to, then for one single iteration, what we're kind of doing is we're looking at each pair and we're splitting it apart. And when it splits apart, it actually becomes 2 new pairs. One pair where the first element is paired with the center replacement, and the other pair where the center replacement is paired with the second element, right? And so what I think we want to do is create a hash where the keys are each of the possible pairs, and the values are the number of times that those pairs appear in the string. And what we can do is then we can, every time that we want to take a step, we can just look through all of the keys that have any values, and then that many times we'll sort of split the key. So we'll need to like subtract the ones that are being removed from the string. We'll need to add ones that are being added to the string. So it might be a little tricky, but we'll figure it out. So let's change our representation, polymer or day 14 spec. I think this is, we're not actually using the test very much, but, and we don't actually want to care about the template anymore. I guess, in fact, like the template is going to become a dictionary that will be something like A, B points at a number. And then actually, so yeah, let's keep this around for a second, because this is going to be, this string value will be interesting. So we want to go through that string value and say that like the result should be something like AA points at 1, AB points at 1, BA points at 1, and AC points at 1. And then we're also probably going to have AB points at 0. Or no, AB is in there. Okay, so, or no, BC points at 0. So BC was one of the original pairs, but there is no BC anymore in this list, so that should be a 0. So that's kind of like the new representation that we want to have. And I missed a comma somewhere. Yeah. Okay, this is what it is now, but we're going to change how that works. So for our template, instead of storing it as a string, what we want to do is we want to store it as a dictionary. So let's use hash.new0, because we're going to use a counter of those pairs. And then we want to say template.chars.each cons 2. So each consecutive pair of 2, again, we're kind of using the same situation here, do pair. And we're going to say at template at pair plus equals 1. That should give us the count, I think. Well, that should give us, let's actually not step. Well, okay, so let's confirm that after we first create our situation here, we end up with AB points at 1, and then BC points at 1. It's like right after we initialize, that's what we should have. Okay, so those pairs did not, again, we have to join. I wonder if we can map to and join here. Both block and arg actual given. Oh, and then dot each. Okay. I wonder if we can just tally at template equals this thing dot tally. Does that work? Whoa, sweet. Okay. So that's totally what we want. Tally. Gosh, that is such a cool thing. I learned that from Colin Gilbert and Roman from RubyConf. Tally is that's a fun one. Okay, so at this point, we have our template, we have our mapping, and we need to update our step logic. So now what we want to do is we want to go through each pair of each pair of letters inside of the keys for the template. So template.keys.each do, in fact, yeah, keys is template.keys. And then we want to say keys.each do key. And first we have to, let's see, subtract key value. I don't know. So inside of template, so at template at key. Oh, you know what is going to be bad about doing it this way is that we're not going to have a default. We're not going to have a hash default, which we do want. So let's go back to what we had before. Yeah, this is actually like superior here. So we can say dot each do pair again. Okay, I see. All right. So instead of chars, we want to say keys. So keys is template.keys. The reason why I'm pulling off template.keys here is that while we're iterating, we're going to be modifying the template, and I don't want the template to be changing underneath us while we're iterating over it. I don't know if that makes any sense, but hopefully it does. Okay, so here what we're going to do is we're going to say keys.each do key. Now, what we want to do is we want to look at the template at the key. That's going to give us some value. And that value is important because that's how many times we want to split the key. So the key.chars, I guess we also want the mapping. So char is at mapping at key. And now what we want to do is we want to split the key. So we're going to have A and we're going to have B, and that's going to be key.chars. And we want to combine A with char and B with char and increment the occurrences inside of template, the value number of times. So what we want to do is we want to say at template at a char.join plus equals value, and at char b.join plus equals value. And then we want to say template at key minus equals value, because we're in the next step of the string, we've sort of split apart that key, so it should no longer be in there. But as we're iterating through the keys, we might encounter one where when it's being combined with something else, it ends up adding values to this. So those numbers are going to kind of like shift over time. Okay, so what does this actually look like? I don't know if we want to join any results or anything, so let's step and then see what we end up with. No method chars for hash. Do we call chars somewhere? Oh, down in score. We're not calling score anywhere, are we? Okay, so let's see. Oh, this, I don't think we want that anymore. Okay. We do need to somehow figure out how to deal with that first character again, but we'll come back and try to figure that out later. Okay, so that's great. So now we have something that looks somewhat like it's working. Okay, and I hope this makes sense. We're kind of like, yeah, we're incrementing and we're splitting apart and then we're putting it all back together and we end up with this big template that should have something for us. Okay, so then the next thing was that we wanted to run it 40 times. And what do you get if you take the last quantity of the most common element and subtract the quantity of the least common element? So we're doing the same thing again, where we need to get the quantities. Now, the problem with this is that when you're looking at the template, like ABC, right? If this was the template, the original template, our new template is going to be this dictionary that has like AB points at some number, and then BC points at some number. Actually, this is going to be 1 and 1, right? And so one thing that we could do is we could say, all right, show me all of the letters, the individual letters as like A. We're going to kind of just like look through every single key, and if A appears in that key, then give us the value for that. So we could say A points at 1, B points at 2, and C points at 1, right? Because B is in this one and it's in this one. And then we'll just be off by 1 for the first letter and for the last letter, or maybe just the first letter. If we take all of these and then we divide by 2, I think we might be in a good place. So what we want to do is we want to iterate over the template keys again. So we're going to say something like at template.keys.each do, actually we want to iterate over both the key and the value. So we'll say template.each do key and value. And we're going to kind of keep track of a new dictionary of sort of frequencies. And it's going to be hash.new of 0 again, because we're going to use this sort of counter style. And in fact, actually, yeah, like the frequency, I think we're going to want frequency.values minmax inject again, that whole thing. Okay, so freq is a hash of values where we're going to have a single letter pointing at its value. So now we're going to, actually we can kind of, well, yeah, okay, so here we want to split the key into A and B, and that's going to be k.chars. Actually, let's make this a little more clear. Okay, I don't know if that is more clear or not. Okay, so then we want to say freq at A plus equals value and freq at B plus equals value. And then I guess, yeah, we want the min-max. Min-max is equal to this. And then we're going to say the return value is going to be max divided by 2 minus the min divided by 2. Because I think, yeah, I think if we divide by 2, we should be okay. Maybe we can, yeah, let's do it that way. Let's see what happens. All right, so do we have an example? We have an example. So from the example input, I think we're supposed to get back this giant number. So if we just run against example input, we get a giant number. Let's see if it's the right one. It is not the right one. Okay, so let's make sure. Actually, should we just do min minus or max minus min and then divide the whole thing by 2? I don't know. Let's see. Same number. Okay. Math. Gosh. Transitive properties. I don't know. Something property. Something. Okay. So in the first example, what we did was we only incremented it for. Gosh, okay, so what is going on with our logic here? All right, so we're stepping, we think that the step is increasing as expected. Why don't we step again, polymer.step again. And now we're gonna have to build out our map a little bit more because we don't actually have a let's make that also go to A. Just to, like, the more we can collapse on A, the better. So this is going to end up with, so yeah, our old one was A. Gosh, it's so much trickier. So we had all 8. Stepped again, we're going to get AA, BA, C, and this one is going to become A, BA, C, A, right? So now we should have 1, 2, 3, 4, 5 AAs, and we should have 1 AB, and we should have 1 AC. And we should have, yep, 1 BA, and I think, okay, so I think that's right. But that's not what we're getting. We're getting 6 AAs because, again, I wonder if we need to do this situation here with the very first time through. I don't know if we want to actually increment that A thing. So I equals 0, I plus equals, actually, yeah, we can just do each with index, and say this is I, and then say like, if I is greater than 0 or something. I don't know, like, that's a different number, but it's not the same number. And okay, so does that work? That does not work. And we end up with the wrong template. There's no AAs. How is that possible? Oh, because we're not ever adding it, right? Okay. Okay, so I think there's a bug here where we're reading out this value, but then we're like updating the value directly as part of the step. And so what I think we want to do is actually split out and create like a temporary template, and then use that template as like a 2-step process where first we kind of like update the temporary template. Template is going to be hash.new of 0, and then we will update the temporary template. Template. And then after we've gone through and updated the temporary template, after we've gotten like all of our numbers based on the current values that are in the template, then later we'll go in a second step and we'll update these values. Because what we're doing right now is we were overwriting what we were reading, and that was messing us up. So keys, let's see. I bet there's some sort of merge thing we can do here, but let's just do it the hard way because we don't know. Actually, yeah, let's iterate through template. And we don't need an index, we just want key and value. And now we're going to say at template at key plus equals v. And it's possible we're going to get negative values, and that's okay for the template. So let's run this again. Or let's run our test again. Okay, now our test is passing. Now let's run it against the example input again. Okay, that's a different number, and that looks promising. And, ooh, it's so close. 218, 818, 969, 3528. Wow, we're just off by 1. Okay. Maybe this needs to be like dot ceiling or something. Or like, yeah, make this a float and make it the ceiling. I don't know. Maybe that's cheating, but we're close. We're super close. All right, so now let's do 40 steps of our own input and see what we end up with. And okay, 372. Okay, so that was my puzzle answer. So that was the answer. All right, so if we come back through this, so the bug was that we were overwriting while we were iterating. And what's really cool is that old solution would have taken a super long time to finish, and this solution is lightning fast, again, because we're using hashes instead of arrays, or instead of strings in this case, because we don't need to build up the entire string. We can just kind of like keep counts of things and shift them around. That is it for day 14 of the Advent of Code with Ruby. Thanks so much for watching, and we'll see you in the next one.